So the first thing is step-by-step download, how to download R and R Studio. So downloading is easy, installing is much easier. All you just have to do is accept and press next. So to download and install R, which is the first thing you have to download. R is the R console is like the engine, is R itself, while the R Studio is the IDE. That's have two softwares. We have R and R Studio. R Studio is the IDE of R. IDE is Integrated Development Environment. If you open R and open R Studio, you would understand why it is integrated. It's much easier to use in R Studio than in R. All right, so the basic, like I said, the basic thing is just download and install R first before installing R Studio. So that's how it works. So download and install R. And go to this website, the CRAN R project. Okay, so this, if you have the PowerPoint, you can copy and paste the website on Google or on your browser, and it brings you to the page that is already screenshot here. Just download the R 4.2.1, then it's just follow the steps in this slide. Right, you have to save it to get it into your download. Save the executable file in your download library. Then you double click, just like installing the normal software. Double click on it to start the installation process. Then click on run, and just the other thing is just click accept, okay, yes, next, and so on. You have to agree to terms and conditions. And so once you are done, you should have the R icon on your desktop. So I want to show you the R icon. This is the R icon. You should have it on your desktop or on your files menu. That's where you have your programs. It depends on the OS you are using. If you are using 7 or 8, you should have it on your programs. And if you are using 11, you should have it on all apps. Then to install R Studio, so this is the logo for R Studio. Still, you can copy and paste this on your browser and you get to this website. Install the free version. Free version is enough to do a lot of things. Then click on where you have this the Windows, based on the OS you are using. If you are using if you are using Windows, this is for you. Then select save, go back to your downloads and run it again. So once you start running it, just accept, run, next, okay. So you are done with the installations. Okay. Then select yes until installation is done. So when you are done, you should have it on your desktop or on your programs or all apps. Then you are ready for this class. So if you've not done that already, you can do it while we are starting the class, or you just follow the class and watch the videos later. So they can follow as we go. As you watch as well. All right. Did we all get that?
Yes, I think you
Hello?
can continue.
All right. All right. All right.
Yes.
So after okay. So after the installation of R and R Studio, the first time you open your R Studio, this is what you have. So this is what's something like this. Your console here might be a little bit smaller. I increased mine. You can always adjust these 4 panels that you have here. All right. Now, okay, it's 3 now. Well, it's going to be 4 very soon. So let's make it 4. If what we'll be using today and throughout this series of classes is the R scripts. So now this is the console. Okay, let me just bring out the R script so that I can explain everything together. To bring out the R scripts, it comes to File, New File, and R scripts. There is no one way of doing this. You can also come to this plus sign, the plus sign down here, or this arrow down just beside the plus sign, and select R scripts. So the shortcut for doing that is Ctrl-Shift-N if you like shortcuts. So you can go through File, New File, then R scripts. While you can also go through the drop down beside the plus sign and click on R scripts. All right. Okay. Now this is the R script without anything. This is the first thing you're going to see. So now we have four. The panel is complete. We have four pans. This is the R script. We have the console here. Let me bring it up a little. All right. So this is the R console telling us the version of R version 4.2.1, and the name and all of that. All right. Now the console, like I said earlier, is the R software itself. It's the engine that runs everything we put into R. It listens, it gives us feedbacks and all of that. All right. So it's really simple to use. Now, when you have prompts, this greater than sign, it means R is ready for you. R is ready to access or listen to you. So, example, you can do 6 plus 7 and enter. So we have 13. So this is the console giving us output for 6 plus 7. So if it can do this, it can do every other thing. Now the one here indicates that that's the first response for this query, for this command, or for what we've written 6 plus 7. There's some commands that brings out 2 outputs. So if in such cases we have first output, second output. All right. So that is the console. If I come to the script here, I can also do the same thing. 6 plus 7. Now, there are several ways of running the scripts. I can, as long as I'm on this line, I can highlight it, and I'm decided not to highlight it. So if I do Control Enter, or I click on Run, it runs, gives me the outputs here in the console. In the console as well. All right, so let me do that.
Mr. Timothy, sorry for this.
All right, sir.
Mr. Timothy, can I just
yes, I can hear you.
Brief.
All right, sir.
Okay. All right. I suspect a good number of us in the class may not be familiar with R at all because we're taking it from the basics. I just want to plead if you can give a short background to R as well, the use and the benefits, something very slight about R.
Okay.
I mean, very light about R before we go to some of the specifics. Thank you very much.
All right. Thank you, sir. All right. So R is a tool for statistical programming, and it has over the years it has gone over statistical programming to giving reproducible research. Reproducible research. So that is beyond the scope of what we are doing now. We can also use it to create apps. It's a very, very versatile app that is, and it's there's something that is usually, or how would I say now, frequently said that R is a proper language for data science because it is designed by statisticians and for data science. Unlike Python, Python works fine too, and I use Python too a lot. But R is much more proper. Maybe because I'm a statistician, or let's not go into R and Python, but it's just like other softwares that you use for programming. But here we are using, what we are doing in R is statistical programming, and it can be deployed or applied across different fields. We use it in research to produce, you can use it to produce a whole paper itself, like a whole reports, PowerPoint, PDFs, HTML, websites, and so on. And it's an upgrade of the S language, and R is becoming we have libraries. I'm trying to limit the things I say because it's I don't want to go into.
Yes, I don't want this to distract you in any way. Just I think you are good.
Yeah, so it's a programming platform that we use for data science. It can do arithmetic works, statistical, from basic to the very tough ones, and almost everything you want to do is in R. You can even use R instead of Microsoft Word and all of that. Depends on your level of proficiency with R. All right, that being said, so let's continue with this. I hope I've thrown a small light on what R is.
Yes.
All right.
Yes. Thank you, sir.
All right. So I was talking about the first panel. I mean, the first panel, that's the console. Now the scripts. So I'm writing the same 6 plus 7, and I can run it with Control Enter. I prefer using keyboard than running it. I mean, coming here to click run. All right, so I can do something else. 5 minus 3. All right, and come here to run. Now you can see the outputs at the console. 5 minus 3, 2. 6 plus 7, 13. All right, so scripts is like the normal scripts we have, like writing a play. So the good thing about scripts is, if 5 minus 3 is what I was intending to, is not what I was intending to write, I can go back and change it to 5 minus 4. Then run it again. So script is editable. While console, you may not have that flexibility with console. Although I can use the arrow, I'm now on the console. I can use the arrow up. You can see my cursor here blinking. I can use the arrow up to go back to my previous command and change it to 5 minus 2, then enter. So to run any command in the console, you use enter. But to run a command in the scripts, you use Control Enter. So as I was saying the other time, if I want to change what I've written in the console, I can't erase what was done before. I can only call it back using the arrow key and edit it. Like I can call anything, this is 5 minus 2. That's the last previous thing that I just did. And then if I press arrow up again, 5 minus 4, arrow up again, 5 minus 3, 6 plus 7, and okay, this gets WD, something I did before. All right. Okay, so that's the difference between the console and the scripts. So now, how does that apply? After editing, I only leave what I want on my scripts. The errors, I can delete them. Then when I save my scripts, I can run everything from the beginning to the end. Now, let me do something. 9 divided by 3, and Control Enter. All right, so now what I want to do now is that, okay, fine. Now you can see here, there's a white space here. R does not really interpret white space. So while I can have white space between my commands, I can also decide not to have white space between my commands. It's still going to run it for me with white space or without white space. All right. Now, what I was going to do was, you don't have to run everything line by line. Do I prefer running line by line as I am working on a project? But if it's something you've done before and you've tested it to be fine, you can run everything, or you can run a few lines at the same time. So when you want to run a few lines at the same time, you can just highlight everything and Control Enter or run. So for me, I find Control Enter much more faster than coming here every time to click on run. So sometimes often when I say Control Enter, it means run. All right. That means you press the Control key and Enter on your keyboard. They are close by, so you can just press it at the same time. All right. So that's about the scripts. Scripts, you can edit scripts, you can change it to whatever you like. Now, the other panel, or the other pane is the environment, the global environment pane. Here you have the environment, you have history, the things you've done before are saved here. So every time you want to close R, it will ask you, should it save the history? If you click yes, it saves it here. And if you click no, it won't save it. Then connections, this is if you have connections with other tools like SQL, you're working on different projects, they're working on projects that has to do with several apps or packages, you see them here. Then you have the tutorial. This is quite new. It's a tutorial from R that you can go through yourself to understand how all of this works. All right. So in the environment, will most likely be here. In the environment, everything we do, anything we save here in the scripts or during the project will be saved here. For example, we've actually started the class. So let me put class, and I want to create an object and save something there. Save. Okay, so I can't use class. I'm going to use class. All right. And 4. All right. So what I'm doing here is I'm assigning 4 to class.
Hello, sorry, Mr. Ibami.
Yes, sir.
You need to maybe raise your voice a bit, just a bit, please, so that
oh, okay.
everyone can hear. Yeah.
All right. All right. All right. So I was saying that here I want to demonstrate what the environment does. So I'm assigning 4 to an object or a variable called class. So how do we assign something to a variable or an object? A variable or object is the same thing. All right. So now this is what we use. This is the most proper. We'll still get to this in the course of the class. But for now, less than and the dash is what we use. Now, Control Enter. Now you can see class here. In the console, there is no big deal. No big deal. Nothing big deal happened in the console because it just repeated what we did in the scripts. All right. But in the environment, it saved class as it saved class and gave it 4. So every time I call class, and okay, let me just call it. Every time I call class, Control Enter, it gives 4. I can also do class plus the Control Enter, and it will give me the answer here. Okay. All right. So class plus 3 will give me 7. So class becomes an object that is saved in the environment. So that's the work of the environment. It saves every object we have, that we are presently using in the environment. Now, the fourth one is where we have the files and packages and plots and all and every other thing. So files it shows us everything on our system. So to have access to, while using R, you really don't have to go back to your desktop or documents to open your folders or your files. You can do them here. If there's any plots we are using during the project, it shows here. Then packages are extra vocabularies. Like R is a language. Packages are like the vocabularies that contains different formulas. So if you are installing for the first time, you might not have some of these things I have. But as the time goes by, when you use packages, your packages will be updated, like you have a lot of them. All right. So, but by the time when we get to other classes, you would learn about packages. Then we have the help and the viewer and presentation. As I said earlier, that you can use R for presentations. You can use R to create presentations. All right. So let me leave it at packages. Now, I have done a few things here. 6 plus 7, 5 minus 4. Now let's assume this is the whole thing I'm doing in the project. Now, I shouldn't wait until I'm done doing all of this before saving my work. Now, but for the purpose of this class, I'm just trying to take it one after the other. Now, to saving is very, very important. We are not online. Like the R is not online. So it's important to always save. Anytime we are on these scripts, this Untitled 2, anytime the script's name is red, that means you are yet to save. Now, where do we save? To start any project, before you start any project, you should actually have a file that you want everything you use in that project to be stored in a file or a folder. So for the purpose of this class, I'm going to be using my desktop. However, so that file is called working directory. So now I want to check where R is going to save automatically. Like where is it going to save the things? If I just do Control S now to save, where will I get my my files? So to do that, to get to know where my working directory is, I can write the command get wd. Wd means working directory. Get working directory. Then I pass an empty empty brackets, then run it. Now, in the console, I have C user documents. By default, R saves in documents. But you can guess my documents is flooded. Like I'm sure everybody's documents, you have a lot of things in documents, and you want to save your scripts just anywhere where you have to be looking for it. Things can get lost, it can get missing, or not found. Let me not say missing, not found on your PC if it's not properly kept. And that can be very, very, it can give a big headache. So how do we go about creating a working directory or setting a working directory that we want? Now, you can come to file to create a working directory, to tell R that everything I'm doing on this project should be saved in this particular in this particular place. Okay. Okay. All right. So come to session and click on set working directory, and you click choose directory. It's also possible to set a default working directory for all your R works. Like if you want everything you ever do on R to be in the same working directory, you can do that. We'll get there very soon. All right. So I can navigate to anywhere I want. Like I said, I want mine to be saved on my desktop. All right. So if you want to create a new folder, you can create new folder here. There's also a way you can do this using codes, but sometimes you can forget code. I just need to show you that you can do it with point and click as well. So clicking new folder, I'm going to call it class 1. And open.
Please,
right.
please, sorry, excuse me.
All right.
Hello. Yeah,
Hello,
please, can you run that? Yeah, sorry for taking you back. Can you run that step back? Saving,
okay.
Creating new folder.
Okay. All right. So I went to session, then set working directory, and I went to choose directory. So here on this pop-up here, I have new folder. Okay. So because my directory is already in class 1, so it's open class 1 already. So if I want a new directory, I'm going to click new folder and then create a name for the folder and put it, then click open. I don't want to do that again not to mess up my working directory. All right. So let me quickly state that if you have questions, you can put them on the chat box. And there's some things we can also get back because these videos will be sent to everybody. So there's some things we can get back on the video. So all right, let's go. So the code, instead of going through the point and click, the session and set working directory, the GUI, we can actually write this code, set WD, to check we did get WD. Now to set, you can do set WD and then put the name of the file we want to we would like to save our works into. This is the path to that file. So if I should run get WD again and enter here, it would. So you can see now I'm on desktop and class 1. Let me save this now. Go back to the scripts and I can Control S. The normal way we save things, save files. So I'm going to call it rough. Just rough 1 and save. Now, can you see my desktop? If you can see my desktop, then a new folder has been created here, class 1. So if you open class 1, then you will see the R scripts in the class 1 folder. So everything I do going forward, if I create a new script and save, and create another new script and save, it saves in, you can see rough1.r. That's the folder, the scripts I just saved that I'm using presently. All right. Okay. So that being said, let's go into today's what we have for today. Now, 3 minutes. Is there anyone who has questions? Something you want me to say again? All right.
Okay,
There is no. Okay. Good evening. Okay.
Good evening. My R is only having file, edit, view, MISC, package, Windows, and help. It's not having that code,
okay.
view,
Okay.
session.
Yeah, it's not white like this. Yeah, it's not white.
Yes, it's not white like that, and it's not even having the environment field, the one that has system, library, all those.
So you are not on R Studio. You are on R Console. Have you downloaded R Studio?
Okay.
So this is what you have. R.
Yes, that's what I have.
Yeah. So you should have. This is the icon for R Studio down here. So this is what you have.
Okay.
Yeah. So this is the console.
Yes.
This console Yeah, this console is also is what we have here. Is this whole console? You can
Hello, sir. We
see
cannot hear
R
you. Your
version
voice is not
4.2.
it's not clear.
Eh?
Okay.
Okay.
Hello. Hello.
Yeah, I can hear you, Doctor. Yeah.
Yes, we are able to download the R, but the RAM
Okay.
video we downloaded it, but it's not installing on our desktop.
Wh-
So how do you go about
Which
that?
one? The R
Sir,
Studio.
increase your volume. We cannot hear you.
I'm actually shouting now, and it's very peaceful here.
Are you listening?
I don't know whether it could be a matter of networks.
I can hear you. Yeah, I can hear. Maybe it's network that's your.
Because I can hear him clearly here.
So
Hello.
the R video is not installing.
R Studio.
Yes.
Yeah. So
Hello.
there's a requirement.
Yes. I already installed the R.
Okay. There's a requirement on.
Hello.
Now I followed the process. I downloaded it. I make sure the free version, and I downloaded the free version.
Yeah.
And I installed it, but it's not appearing on my icons. Yes.
Okay. Go to all programs and check for R Studio. It should be a folder. Click on the folder. Then you see the icon there.
Okay, sir.
Okay. Let me try it now. I'm using the window.
Windows Z7, 8, 10.
Yes.
Which one?
Window 10.
10. Okay. You should have it. Just go to all
Yes.
Z apps now, all programs. Then you would see it. In fact, it should even come out first. Latest. It should be under latest. Then you will see it there. All right. So
Hello.
Thank you. Yes, I've seen it. Yeah. I've
you
seen it.
see
Thank
yeah.
you. Yeah.
All right.
Hello, good evening.
Sir, I have a question.
Okay. We have to move. Okay.
Hello, good evening.
Good evening.
Yeah, thank you for the lecture so far. Please, what and what do we need to download in order to follow, to just follow as your training?
Okay. Can you? You need to download R. I need to download R Studio. So there's a slide, a Google slide in the class. That was the first thing I
Okay.
created. So just follow. It's a
Okay.
step-by-step guide on how to download and install. So you download
Okay, how
R
can we get
first.
access to the Google slide?
It's on the you are in this class. So just click on classwork.
Yes.
Yeah, just click on classwork. Then you see the R scripts and different. You see presentations and presentation slides. So under it you see how to step-by-step guide to download and install R Studio. So you just Google download it and install it.
Okay.
It's very easy. Then Google download R Studio,
Okay.
download it and install it. You just keep pressing I accept, yes, and next till you are done with installation. So where we are interface. So once you are done with both, remember to install R first before R Studio. So when you are
R
done with,
Studio. Okay.
yes, when you are done with both, then open R Studio, then you can follow us. All right, so we have a lot
Okay.
to cover today.
Thank you.
We have a lot to cover today. So let's get into today's class. Now, I have a script. A ready prepared script. You should all have it too. So it was sent to our emails and it's on the class board as well. R Basics 1A and Part 1A. So if you don't have it, you can go to the class activity or class work now and download it. Then, or just pay attention. You can do that later. All right. So now I have I have it in this folder. So I want to go into my R to bring it out. I'll go to File and okay, open File. Now it's taking me to the working directory, but what I want is not in the working directory. So because I know it's in the desktop, then pilaf R and module 1A. For you, you might not have all of this, but you must have seen this R Basics Part 1A. So you must have downloaded this during the day or right now. Anywhere it's probably is in your downloads. If it's in your downloads, you just click on downloads here and you get it there. All right. So desktop, go back, pilaf R module 1A. So anywhere, just navigate anywhere you have your downloaded R scripts, and you can double click or click it once and click open here. So it's going to bring out my R scripts, and that's what we'll use for the rest of the class. Hopefully in the next 1 hour, we should be done. All right. Okay. So you can see it's quite different from what we have in the rough 1A. This is not a rough work. It's much more prepared. All right, so because I don't need the environment and the files panel right now, I'm going to shift it to the right so that I can have more space for my scripts. All right. Okay, so there's one more thing I need to show you is the global environments where you can set you can change different things on your RStudio, because you might see some RStudio that's quite different from this. You can customize yours. Just go to tools and go to global options. Tools, global options. There you can change the appearance. If you prefer your console to be by the top right and so on, you can do all that here. So general, this is where I said you can actually make your working directory permanent. So default working directory when not in the project. So if you want to change that, you can change it. But for me, I've left everything as default. That's how I've been using my R. And the code, you can change how your code also appear, and your console also the appearance. This is my favorite. You can decide to change it to any one. Default is 10. I changed it to 10, to 14 because of this class. That's for the font size. The default font size is 10, but you can change it depending on what works for you. Then the theme, if you like the dark theme, and it's just cool to leave it as default. Like everything is fine at default. So here you can change for sources where you have your scripts, your R Markdown, the R presentation, and all of them. You can decide to make the upper. So this is the panel. It's customizing your RStudio. There you can check them out later. All right. So we've talked about 4 panels of RStudio: working directory and tools. That's the global options. Now, you would imagine why do we have this as green? Now, here line starting with hashtag. This hash as this as comments lines. Okay, so I think should be so line starting with the hashtag and comment lines. Like when we're working the other thing, we did 6 plus 4, something like that. If I press enter, it goes to the next line. Now that the line of 6 plus 4 is a command. While this line now, because I'm starting with an hash, this is a comment. So this is a comment. Now it is green because R is telling you that it's not going to run this. Now it will run it, but it will not execute it. Let me highlight both of them and run. And see, I have 6 plus 4 is 10. It has an output. Then this is a comment, just appears like that. This is a comment. Then it is not executable. You can't execute it. So comments are really, really, really good. Cultivate the habit of using comments everywhere possible along with your codes, because when you work on something, a project you work on today, 2022 September, you might need to pick it, or you might not have any need to pick it back until 2025 December, and you might, without comments, you will not perfectly understand everything you've done. Trust me, you won't. So it's good to put comments while writing your codes. You will see how I have applied this very soon. All right. So they are like the lines that start with comments or anything after comment, after the hashtag, are ignored by R and serve as a note to the user. In the scripts, okay, yeah, we've talked about that. In the scripts, run your lines using Control Enter. That's the scripts where we are now. You use Control Enter, or you come here to click on Run. While in the console, you run with Enter. Pressing Enter in the console works without pressing Control Enter. All right. So I wanted to demonstrate 6 plus 4 Enter. Just pressing Enter would work in the console. You have to run with Control Enter, or you come here and run and click Run. All right. So for the person who opened the other R, the R console software itself, over there to run anything is you use Control R to run it in case you are still there. And actually, anything we run here will also run on that R. All right. Now, the person is referring to this section of the scripts. All right. This R script should be executed line by line. Like I've said earlier, you should execute line by line. 1, one reason why this is good is because it will help you in debugging. If you have errors, you know exactly where the errors are from. Of course, there's some codes that are written in chunk. We are not there yet. You might not be able to run those ones line by line. But anyhow, you run per line or per concepts so as to quickly detect where you're on Windows, all the scripts from the menu and execute line by line as well. So to execute on Macintosh, you just use cmd return as a command and return. Return in, okay, for those who are using it, understand what I'm saying. Enter is for Windows and return is for Mac. All right. Code sections or folding in the RStudio IDE. Now, I'm saying this because in this section, in this scripts, they've been organized by sections. All right, like here, I can click. There's this arrow up and down here. It helps me to quickly navigate to different sections in these scripts. There's printing, vectors, matrices, lists, arrays, R as calculator, and all of that. These are sections. So how did I do this? All right, so that's what I want to explain now. So code sections allow you to break a larger source file into a set of discrete regions. Now, for easy navigation between them, code sections are automatically foldable. For example, the following blah blah blah. So let me just show it instead of reading. Then auto suggest. R helps to suggest whatever you are writing. So if you want to write I'm going to show that later. If you want to write mean, for example, MEAN, by the time you type MEA, usually when you type the first three, R suggests, you can see, so it suggests for you what you want to write. Are you trying to write mean or mean dates and all of that? So if I'm trying to write mean, I can just accept it with tab and it opens the bracket for me. I can do mean of 3, 5, and 6. Then, yeah, so mean of 3, 5, 6, I have 3. So it's that easy. Now, section A, this is the first section, and I'm going to show you what I was referring to by saying that our script is foldable. So this is the first section in this script. Now, the arrow down here, I can fold it. That means everything in this section will not be visible to whoever is saying it. Now, let me show you section B. This is another section, section B. Now, I can fold it here by clicking here. So I can't see anything. You can see from line 32, it's jumped to line 42. To unfold it, I click here and it brings it back. How can you achieve that? You can achieve it by using the hashtag or this dash, yeah, or the dash sign. Now, I can have the hashtag as long as I have 4 at the beginning or at the end. It creates a section. Now I have, now I don't have any. Let me, yeah, because if I remove this, it's no longer a comment. It tries to see it as a code. So R is trying to tell me that this is an error, this is an error, this is an error. All right. I can also do this dash 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 4. Okay. Let me just use my comments back. Oh, sorry. Not so much. All right. So now, once I have this, I have a section. Now, whatever is written here can be folded. I've said that and I've demonstrated that. Now, print pilaf R training. Now, like some other softwares like Java, Python no longer does that. But Python, too, the print function is a very popular one. And we are printing here. We could also use prints, but R is beyond that. You don't have to use prints every time. So print just means replicate, like say it or execute it. Print pilaf R training 2002. Now, this is in double quotation because it is text. It's without putting the double quotation or single quotation, R would want to see it as a command, which once, of course, it's not a command. All right. So let me put it back. All right. So if I run this now, it's just going to print pilaf R training 2022. All right. So what I'm doing here is just to populate this section. To insert section, Ctrl+Shift+R to jump and all of that, to fold and collapse. I have shown that. All right, section B. Okay, note that as illustrated above, the line can start with any number of hashtag or pound as long as it ends with 4 or more. So if it ends with, yeah, that's what I was trying to do the other time, this dash or equal to or hash, as long as there are 4 or more, it becomes a section. If it is starting, hashtag for hashtag can start a section, and for hashtag can also close, can start a section after the name of the section. All right. So why is this good? If I click this again, so section A, section B. So to go to section A, I don't have to navigate by scrolling up. I can just click on section A and it takes me to section A. This is section A. So any section I want to go to, instead of scrolling one after the other, I can just click on the name of the section and it takes me there straight. All right. Now, like I said, you don't learn anything by quickly clicking through the commands. Here I'm trying to tell us that, yes, during the course of this class, you can also click with me as I click, but I would advise that after the class, you actually type out these things, because typing it out makes it more real and you become more conscious of what you are learning than just highlighting or running it or just running it along with me. Because you have it, you might be tempted to just run, and because you have the answers and you have the outputs, you feel you know it. But typing it actually makes it more you own your learning. Like, it's more hard to forget something you actually typed by yourself. All right. So like I said earlier, having your script title or script heading in red is not a good practice. R is screaming to you with the color red that you have not saved. So if I do Control S, no more red, it's saved. All right. Now, using R as calculator, just like most of other softwares like Excel, plus is addition, multiplication is the star. Okay. Everything here can be run. Control Enter. You can see 142 plus 347 is 489. 3 times 6 as 3 star 6, that's multiplication. If I run that soon, I have the answer. Then 5 raised to power 2. Now, I can also do this using the double star and do 5 star 2 and run. So it's the same thing. So you can use the caret, or you can, this arrow up here, like the arrow pointing up, is called caret. And you can also use the star, double star, as power. Then division, you have the backward slash, 21 divided by 3. Now, we can run 2 operations together, 2 or more operations together in R, as long as you break it with a semicolon. So here we have 2 raised to power 6 and 7 divided by 3. So here it's going to give us 2 outputs. We have 2 raised to power 6, 64. 7 divided by 3 is 2.33. All right. 4 plus 3 and all of that. We can run this as well. R takes care of the procedures. Now, pi in R can be written as pi. So the exemption of pi and probably some few things, you can write it, because you'll be like, you can query it and say, well, pi is text. R recognizes pi as 3.14 and the value. Then using the exponent sign as well, R is capable of doing that. Then this sign is called integer division. Now, what it does is that 5 divided by 3, well, it's not just divided, it gives only the integer without the remainder. So 5 divided by 3 is 1. Of course, we know it remains 2, but this function does not give the remainder. But this, the other one, the double percentage, that's the modulo division, gives only the remainder. All right, so these things can come handy while doing some of your projects. Exponential function and all of that, you can run all of this in R. You can run them yourself. So here, maximum will return the maximum number out of this group of numbers. We have 4, 2, 5, 1. Of course, we know the maximum is 5. And same thing with minimum, min. And sum is going to sum all of this, like I did mean the other time. So products will multiply everything. Factorial, that's 4 times 3 times 2 times 1. And choose, this is combination, that's 5 combination 2. And we have 10. Okay, so this is a bit mathematical. All right, so further functions that you can try, we can't exhaust everything. So there are other things you can try here. We have the log 10, log 2, the trigonometric functions, and all of that. All right, so let me take the help function before I give space for question. Now, sometimes you are looking for something, you're looking for a function, or you know a function, but you don't know what it does. So for solve, for example, you want to know what solve does in R. If you type help and into bracket solve, it displays an help page for the command solve. So there's a command you can see here. Let me extend this back. All right, so solve a system of equations. So it's going to tell you what it's about. So you actually say with R, I was tempted to say, yeah, you don't need Google, or you still need Google, or at least you can get a lot of things from here. So this is even giving you an example of how to solve, how to use the functions, blah, blah, and you can read through. By the time you read through, you should have an idea of what solve does. Another example is you want to know what mean. I mean, of course, maybe how to use mean. You just write it there and run it. It's going to display to you how to use it, give you an example if example exists there. Then the same thing. So instead of writing solve, we can do question mark solve. We can do double question mark solve. Then same thing here. Help.start. For you as a beginner, I think you find this interesting. Help.start. You can try it. Shows you various links you can go to for things you can learn on R. Then I find this also very interesting. Example exponential, that's EXP. Now it's going to show me different ways of using the exponential function. You can see I didn't type all of this. It brought it out for me. So different ways I can use the exponential. You can see exponential. Okay, no, not from there. Let me see where it started from. Okay, here. All right. So here it's showing me different ways I can use the exponential function. Another one is the example star. This is very, note that special characters have to be passed with quotation marks. All right, because star is a quotation mark. All right, so this is different things, different examples you can get using the help function. Now, before we go into atomic forms, don't forget to save. Before we go into atomic forms, do we have any question on how to use the help function or using the mathematical operands using R as calculator for like another 2 minutes?
Okay, sir. Good afternoon. Good evening, sir. Hello, sir. Can you hear me?
Good evening.
Sir, I have a question.
Yeah, I can hear you. Can hear you.
Okay.
All right, sir.
When do we write our command on the script or on the console, or just at our will?
All right. If you want to always have your map and write it in scripts. So sometimes while working, you might test something out quickly. So I'm doing this. I'm doing a project on the script. Really need to find the meaning of something, but I don't want to quickly write it in my scripts. I am quick meaning of 4 and 6. I can end up write it. Before you I said earlier on that script is your drama script, and change it and manipulate it. Keep what you want. At the end of the day, you have to keep your scripts. But for the console, whatever you write in your console but it might not be in your own memory. Like it might not be accessible, like tangibly accessible by you. It can be in R history, but it's not something you go to and get. Whatever you want to keep, whatever you want to always refer to in your mail, you have it in scripts, so you can save it and it's in your directory. But if it's just something you want to try out, something you have 200 lines of code, 500 and so on lines of code, and you want to try something foolish that would probably lose focus and all of that, you just come to the script and to the console, try it out. My take, and now I use it.
Okay, sir. Thank you so much, sir.
What about put it in what I the console for it? What I run the script always comes to the console, but you know, the scripts, we save the scripts, not the console. All right.
Okay.
Any other question?
Thank you, sir.
Thank you so much, sir. I really thank you. The lecture is really elaborate.
Yes.
Look at those single of us here. We are new Guinean, and those who doesn't know much about this are. Earlier you said that to send a copy into our email, So we are unable to download it because there are so many chunks, greetings here and there. I've already overshadowed the main message that's in the material that you sent. Please, after the lecture, maybe you do us a favor to resend the materials for this lecture so that we can preview. We can go back again and try it on our own. Okay, mister. So please, kindly do us a favor.
Yeah.
Yes, sir. And it probably if time permits, we can still cover it again. So because we are a new beginner and we are unable to decode all these things now. So thank you so much.
All right. Okay. You're welcome, sir.
Tim,
So, yes, sir.
Tim, can you just show them the Google Classroom on your screen? You open the Google Classroom and then let them view the different sections and where they can access the materials.
Okay. I'm doing that now. Okay, so and it's it for the person that just asked question now. You can just, even if your mail has gone to the bottom, you can always search. If you write pilaf, this is pilaf. Sorry. If you write pilaf, it will bring every mail by pilaf. I can click on whichever one you want. All right, so this is the classroom, and this is probably where you joined from. So here, up here, you see classwork. Every material that will be dropped, that was dropped, and that will be dropped throughout the course of this training will be in the classwork. So you can also go through the Google Classroom as I'm showing you. You can see all topics. You already have 2 sheets there. So you can see I dropped this 153 and and there's another one, Prof dropped another one earlier. That's the one for next week. So you can always access this from the Google Classroom. Then the R and R Studio installation, this is where I referred the lady to the other time. That's the first slide I showed you. Then the lecture slides. I'm not going to read lecture slides for this class because it's something, slides are something we can read up and it's not as explanatory as what I'm saying. So these are the slides. Then data sets. All right, so for this class, we are not using any data sets, but for subsequent classes, we'll be using data sets. So it's important, 2 or 3 things that are very important. The data sets, before the class, make sure you download your data sets, and the lecture slides, and the R scripts. Is someone using 2 devices? I can hear myself. All right, so when you download the 3, the R scripts, the lecture slides, and the data sets, put it in a folder. That will be your working directory for that class. And just put it in your working directory that you created today. That will be your working directory throughout the classes. So are we clear now?
Yes, sir, we are clear.
All right. Okay, so now we dive deeper. Atomic forms. Atomic forms, we are now in what we call data structure in R. So the simplest one is the atomic form, the assignments, the comparisons and logical expressions. So now here we are assigning 5 to X. I said it can be called an object and it can be called a variable. So the variable 5 is assigned the value, the variable X is the variable, is assigned the value 5. Now, although this is in the scripts, if I don't run it, if I don't run assign 5 to X, the assignment logo, the assignment sign is this less than and dash. Less than and dash. This is the assignment sign. So if I don't run this, it will not assign 5 to X. So because a lot of times, because people, when you have the codes already written for you, you might be tempted to jump that line and run your X. X is nothing. Like you can see, this is probably something I've written before. So this is out of it. It is not 5. So now I have to assign X to 5 and run it. Now, what does that? What happens? Nothing actually happens because here R is just repeating it back to me in the console. But here R is saying, I hear you, I've listened. X has been assigned to 5. And like I said earlier on, when you assign something, the the variable or the object comes to the environment, to the global environment, and you have X and the value 5. If it's a data set as well, you see it there. If it's a list or vector or whatever, you see them all here. All right. Now, if I call my X, I have 5. Remember we talked about print. So I can also say print, print X, and run it. It's still 5. So what am I trying to say? That whether you call it directly or you just call X, it still gives you the same results. So I think writing print is going to save you like 3 seconds or 2 seconds. Calling it's much more neater. Just call X, you get 5. So that is how to assign. I would say that's the most common way everybody assigns. But there are some times you need to assign this way. Or let me just say you can also assign this way. Now, you are using greater than sign here and the dash. However, whether greater than or less than, it has to be pointing to the object. That means we are assigning 6 to X. 6 to X. If we run this now and call the X again, we have 6. So we still have the same X here, and now it's called 6. R has override what we had previously for 5. Another way we can assign is to use equal to. So, like I said here, it is equivalent to the first way of assigning. Now, I said it is unusual. It's not really, if you use it, fine. If you don't, if you use this, better. All right. Now, one of the reasons why I give that, that I give for not using equal to is you can easily write equal to twice. That becomes something else. But if you write equal to once, you're assigning 7 to X. Control Enter, as listened, then X, 7. All right. So either you do it with the less than and dash, or dash and greater than, or equal to. This is how to assign values or anything to objects or variables. All right. Now, it's not just one value we can assign to something. We can assign a whole list of things or expressions to an object. Now, this is X. You already know X is 7. The last thing we assigned X to is 7. X raised to the power 2 plus 3. That's 7 raised to the power 2 plus 3. And the output, whatever output it gives us, we assign it to Y. If we call Y, Y gives us 52. So it's not going to return all of this. It returns it. Because this is an expression. R executes the expression. Whatever is the output of the expression is given to Y. Then whenever you call Y, then the output comes out 52. So again, here I can do Y plus X. So normally, if we have not assigned anything to Y and X, it's going to give us error. But because we have assigned something to Y and we have assigned something to X, so that's going to be 52 plus 7, that's 59. Another thing I need to say is that R is case sensitive. So I have Y has been assigned to 52. Now, remember this is small letter Y. If I assign capital letter Y, I assign 22 to capital letter Y, and I run it. So you can see here, it's kept small letter Y, and it also kept capital letter Y. So R is it understands small letters and capital letters. Okay. So the thing is, for me, I don't like using capital letters. I prefer small letters. I don't want to remember that I'll have to be pressing capital letter. That's for me. All right. If you find it easy to use capital letter, it's fine. All right. Just remember to whatever you assign is what you can call. If you assign to a small letter, you can't call a capital letter. If you assign to a capital letter, you can't call a small letter. All right. Again, you can also assign to a list of words. Now, let me give some rules to naming your variable or naming your objects. You can't start with numbers. No. You can't start with special characters. Like special character. No. You can only start with texts. So in between, you can have my function 1, my function 2, and all of that, as you will see very soon. All right. The funny thing is, you can start with space. This can be very, very tricky, but don't do that. It happens mostly when you're transferring data from some other softwares like Excel and all of that into R, and whoever did the data entry didn't take due diligence to avoid errors like that. But R sees space in that regard. I'm just telling you that it exists. All right, so you can call your object or your variable a word. You can give it my name, you can give it anything. So now, and the thing is, I think it's smart to use something that represents what you are trying to do. All right, here, my function assigned to exponents. I'm going to run that. Here, I have my function here. All right. And here, so instead of writing exponent log 5, I'm writing my function log 5. I hope you get that, because I've assigned exponents to my function, and anytime I need to use the exponential sign, I just need to type my function, and it works. All right. Then I can also assign square roots to my function, and square root of 81 is 9, because I've assigned square root to my function. Anytime I'm using my function, it's giving me the square root of 81. So this is one of the good thing about using statistical programming language. It is very, very flexible. Unlike using the GUIs like SPSS and all of that, you are in control, you are in charge, you can manipulate, you can do things, wrangle the way you want it to appear. All right, like I was saying, that the equal to is different from the double equal to. So the double equal to is called equality operator, and it's a Boolean function. Boolean is something that it gives a true or false outputs. Now, what this is saying is that 4 equal, does 4 equates 4? Like, is 4 the same thing as 4? If we run this, it gives true. Is 4 the same thing as 5? Does 4 equates 5? It says false. You can see the output on my console. All right. Now, again, is 4 the same thing as 3 plus 1? And this should be true. All right. So there's a difference between the single equal to and the equality operator. The equality operator is Boolean. It gives a Boolean response, true or false. All right. Now, again, we have the 3 less than and equal to 4. It's also Boolean. Like, it's also a logical expression. You know, remember we are talking about atomic forms. 3 less than equal to 4. Is this true or false? It's true, because 3 is less than 4. It satisfies it. It satisfies the condition of 3 less than 4. All right. Then 5 greater than 2 raised to 2 times 2. 2 times 2 is 4, and that should be true. Then and so on. 5 greater than 2 plus 3 is false. Now here we have the exclamation mark. It means negation or not equal to. I mean, yeah, the exclamation mark is actually is negative or whatever. So I can also have something like this, 4 not greater than, however. All right. So here we're saying 4 not equal to 3. This time around, this should be true, because it's true that 4 is not equal to 3. Is 3 not equal to 3 is false, because 3 is equal to 3. 2 not equal to 3 is true, because 2 is not equal to 3. So you can have expressions in the left hand side and in the right hand side as well, as long as when you execute them, if the answers equate each other, then it says true. If it does not equate, it says false. Now, again, on logical expressions, whatever is true, and we have the and, whatever is true and true will return true. Now, and is a logical expression. Results is true if both expressions are true. So true and true, when the first expression is true and the other expression is true, then it returns true. Now let's give an example so that I won't just be talking abstractly. And okay, so let's look at the first expression by the left hand side. 4 not 4 not equal to 3. That's true. 2 not equal to 3. That's true. So the and, remember we said if they are both true, it returns true. So if we run this, it is true. Now, true and false. What we are looking at, the operator we are looking at is the logical operator we are looking at is this ampersand and what it does. For the and, the left hand and the right hand has to be true. So if it is true and false, then it's going to be false. Let me do 2 greater than 2. Yeah, 2 greater than 3. So this is true while this is false. Let's see. So because the true condition is not satisfied, so it returns false. And means that they both have to be true. So once one is true, either the left or the right, once one is false, rather, either the left or the right, then it returns false. If both are true, it returns true. All right. Then if both are false or less than, all right, let's see what we have. So if both are false, 4 less than 3, 2 greater than 3. Yeah, if both are false, it still brings out false. False and false is false. False and false can, even in true life, false and false can never be true. All right, so we have and then we have or operator. The or operator, once one side of the expression is true, it gives us true. All right, true and false. True and false is true. So, and false is false. False and true is true. True and false are true are the same thing. But false and false still remains false. So you can use this expression to actually test it out. Let the first the expression by the left be true and the expression by the right be false. Then you see the outcome. All right. Okay. So this is me demonstrating what we already did then. All right. Remember the exclamation mark that we said is negation. So negation true, that exclamation mark and true gives false, and negation false gives true. All right. So 5 is 5 same thing as 5. It is true. However, if we remove the brackets, the negation turns that true into false, then it becomes false. All right. So before I move into the next section, is there any question on logical operations?
I'm sorry. How is the logical operation applied? What's the application, please? Thank you.
Okay, fine. All right. So let me do this inside the console. Now R sees true as 1, false as 0. So I'm going to write true. No, I wrote some true, comma true, comma true, and enter. We have 3. Let me add false. Right. So we have, these are 4 items in the sum. So if I add it, it's still 3 because false is 0. Now, how is sometimes okay, let me share an experience with you. I won't say it precisely. When you're working with large data, very large data, and you know that in this data, there's somewhere, or in this column, there's somewhere that is actually greater than 70, for example. Maybe it's an outlier and it's greater than 70. You can create a new column and create a command by saying that if something is less than, if it's greater than 70, put true, otherwise false. Then you run it. Then you can see true, false, true, false, true, false, true, false, true. Again, if the data is large, you can't, by the time you're scrolling, you can't use your eyes to count how many true, how many false you have there. Remember, false is 0, true is 1. So by the time you just do sum of that column, you can get how many observations are actually greater than 7. So I don't want to, it's abstract, except I show you, but we don't, in this class, we don't have data to demonstrate that. But just that's how it's applied. I understand what I'm saying. It might be a bit abstract to you, but basically that's how it works. This is the sum-ish is a simple example of how it works. So you can use it to know the number of a condition that is satisfied or the number of a condition that is not satisfied. Sometimes if you want to apply another operation on a number that is satisfied, you can also use this, like do an if statement. If true, then do this operation. If false, then leave it as it is. So that's how all these logical operations are applied. Sometimes the and or, if you want to do comparison between 2 columns, what I did, you can say if you have a data on boys and girls, for example, and we collected their heights, and we noticed that the instrument we used to collect the boys' heights has a -2 calibration, and so now in our data, we decide to add 2 to only boys. So we have to write down that if this person is boy, if the person is a boy, add 2. So that's true. That when it is true, add 2 rather. When it is true, it adds 2. When it is false, it leaves it like that. So that's how the logical operations are used in real life. All right. I have to move. So we talked about prints. Print is the same thing as writing square root of 2, square root of 2, and all of that. All right. So here we can also tell the number of digits we want to have. So let me print the square root of 2. rate of 2 is 1.4142. So let's count 1, 2, 3, 4, 5, 6. We have six digits after the decimal points, 7 digits in total. So now, if we want to change the whole digits that R gives, by default, it gives 5 digits after. Okay, it gives 7 digits in total rather. So now I want it to give 10 digits. I'll use this option and this function, options digits equals 10. So if I run square root of 2 again, now if you count, we should have 10 digits. All right. Now, the same way we use print for normal expression, for categorical expressions, we use cat, C-A-T. Now, here I'm going to combine two functions. Three rather. One is the backward slash and n, and then the backward slash and c. The backward slash here, like I said here, produces a new line. Now, let me run this. Cat. Remember, I said for expressions we use print. Then I'm going to run y first. Assign 42 to y. Now, cat. Because it is text, that's why it's in double quotation. Like I said earlier, it can either be double quotation or single quotation. So, and the answer is, so here, R understands that this backward slash and n is supposed to truncate that line, and the rest of the output should be done on another line. So, and the answer is y. Remember, y is 42. So it's going to print 42 here, as I believe. So let me run this now. We have, and the answer is, then it truncates. Remember, after the is, we have the option for truncating that line. Then starts from the second line, 42, as I believe. All right. The other one is text. C rather, it's not text, it's tab. It sometimes gives tab, the normal tab is like 4 space or 5. So this gives 2 or 4 or 8. So today is, then the date function in R also gives today's dates. Oh, okay, sorry. Now, fine. Okay. Now I made a mistake. I tell people error is very good. It makes you learn. What I did was I highlighted only dates. In fact, not even dates. I highlighted ATE and open brackets and then run it. The good thing about R is I can run any part of my expression, just one part of my expression, any part, I can highlight it and run it. That's what has happened here. Because I highlighted ATE and open bracket and ran it. This is what it's giving me. Now, R is telling me with this plus that there's something I still need to run. Like this is not a complete expression, but I know it's an error. I can press the escape button on my keyboard to omit it. Now I have the prompt telling me I'm ready for your command. So that's forgotten that one. So I just told R, forget it, don't worry. I didn't plan to do that. All right, so I'm running this now. So this is where the tab is. Today is, now this is a lot of space. Wednesday, October, blah, blah, blah. And it gave the time as well. All right. Let's see. Vectors. This is very, very interesting. I'll get into the interesting parts of the course, today's class rather. All right, so we talked about atomic forms. Atomic forms involves assigning variables, objects to variables, assigning numbers, operations, then logical expressions, and all of that. Now, vectors is another form of data structure in R. A sequence of elements which share the same data type is known as vector. A vector supports logical, integer, double, character, complex, or raw data types. Now, it's very, very simple to create a vector. Just use C. C can mean concatenate or combine, or whatever. So to create a vector, you use C. That means we are telling R that this is a vector. 2537. In lay times, we can say a list. But after vector, we'll be doing another data type or data structure called a list. So know this as a vector. All right. So 2537 concatenates elements into a vector. All right. So we have, then we can also create different types of vectors. Sequence from 1 to 10 by 3. This creates a sequence from 1 to 10 with step size 3. Let's see what we have there. We have 1 plus 3, 4 plus 3, 7 plus 3, 10. Now, sequence from 3 to 7. Then, if we did not add by 3, it gives a default of 1, 2, 3, 4, 5, 6, just a step of 1. But here, we didn't add it by 3, so it's going to give 3, 4, 5, 6, 7. Running this, you have 3, 4, 5, 6, 7. And sequence 1, 11, 3. So this is a short form of this sequence from 1. The argument is the first argument of 1 here tells R from 1. The second argument tells R where to stop to 10. That's 11 here. Then by 3, is this 3 here. So meaning that give us 1 to 11, but make a step of 3. So we have 1, 4, 7, and 10. It can't give us 11 because 11 is not up to 10 plus 3 is more than 11. So that's where it stops. So sequence of 3 to 7, short for sequence 3 to 7 again. Then another way of writing this is writing 3 column 7. 3 to 7. All right, these are very important concepts. That's why I encourage that even after this class, you need to go over them over and over, because going forward, we'll be applying these things, not just talking about them. So 3 column 7, which is something you would see a lot even in this class, means 3 to 7, like 3, 4, 5, 6, 7. All right. So here, this command says create a vector from 2 to 5, comma, and from 3 to 7. So we should have 2, 3, 4, 5, then again 3, 4, 5, 6, 7. We run that, you can see 2, 3, 4, 5, then 3, 4, 5, 6, 7. So here we not assign it to anything. So this is as good as playing. But here it is assigned to something. 2 to 7 assigned to W. 5 to 9 assigned to Y. Here we concatenate both and make it a vector. So see, if I should call C, so let me demonstrate that thing, the error that happened the other time. You know what I've been doing since is just to run the complete line. But this time around, I want to run only C in this line. So I run C, it gives me the value that I already assigned to it because I've run this before. So W is 2, 3, 4, 5, 6, 7, and Y is 5, 6, 7, 8, 9. All right. So repeat. So or replicate. Replicate first object, that's 3. How many times? 5 times. All right. So if you do this, it's going to give us 3 in 5 places. Then replicate 0, 2, 2. So you can see the application of this 2. I mean the 2, like CO. 0 to 2, 3 times. So we have 0, 1, 2, 0, 1, 2, 0, 1, 2. That's 3 times. We have 0, 1, 2, 0, 1, 2. Again, we have replicate 7 to 9, 2 to 4 times. So this is like mapping. Now, to do this, you have to make sure that the intervals are the same. We have 7, 8, 9 for the first one. Then the number of times we have 3 items. I mean 3 values. So 2, 3, 4. That means replicate 7 2 times. Replicate 8 3 times. Replicate 9 4 times. All right. So that let me just write it out. 7. We have 7. Let me not use comma. 7, 8, 9, comma 2, 3, 4. All right. So what we are saying here is replicate 7 2 times, replicate 8 3 times, replicate 9 4 times. All right. So that is what R is saying when you write this type of code. So now 7 repeated 2 times, 8 3 times, and 9 4 times. Now we've learned about vectors. We said vectors. Let me call the vector C. I mean C again. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what I just did now, I don't have to actually count. I can do length. Yeah, length C. Okay, small letter C. It says there are 11 items in my vector, so I don't have to count like I was just counting now. Okay, so now what I want to do is vector slicing. How do you subset or bring out specific items from your vectors? Again, I want to create a new vector of this 12, 15, 13, 17, and 11 and assign it to X. All right, nothing happens because I'm just assigning it. Now, here, this is how to slide, this is how to select. This is not slicing yet. Select, how to select the fourth item. So when you write X, that's the name of the object. Then 4, that's the fourth position. So let's see, the fourth position is 12, 1, 2, 3, 4. That's 17. So running this command is going to give us 17. That's the fourth position in this vector. Now, again, you can see the application of the 2, like I said earlier, you use it a lot. X from the third position to the fifth position. So the third position here is 13. We have 13, 17, and 11. If you give it unreasonable upper end or upper boundary, say 7, it's still going to give you to where it stops. You can see not available, not available. So, all right, X minus 2. This implies that give me everything in X except for the second object, that's 15. I'm going to call that, we have 12, 13. Okay, of course, 15 has been skipped. 12, 13, 17, and 11. Here again, applying the 2, we have negative, give me everything in X apart from the third value to the fifth value. That will be 12 and 15 only. Yeah. All right. Now we can also do some mathematical operations on vectors. Now, whatever mathematical operations you do on vectors, you make sure, especially if it's vector on vector, you make sure they are the same length or multiple of each other. We'll get there. No, 2 plus, I mean, sorry,
Hello,
253, vector 253 plus, yeah.
Hello, sir.
Hello, yes, I can hear you.
I just wanted to ask a question before you go on. Where we had the 3 semicolon 5, where we had the box bracket,
Okay,
3 semicolon 5.
Yes, x3.
If it had been 3,
yes,
if it had been 3,5, then we would have selected just the 3rd and the 5th. Am I right?
yes, you have to just yes, just the third and the fifth.
Okay, thank you, sir.
Okay, incorrect number. Oh, wait. Incorrect number of dimension. So we have 3, 2, 5. So because the 3,5 gives us it's trying to specify row and column. 3,5 is trying to specify row and column. If we want the 3 and 5 only, let me see. 3,5. Please remind me that later. That's Control Z. Okay. All right. Okay. So operations on vectors. I'm trying to make sure I finish this before time. So like I was saying that we make sure we have the same number of elements in our vectors. 2, 5, and 3. 2, 5, 3, 4, 2, 7. This would easily add up by saying 2 plus 4, 6, 5 plus 2, 7, 3 plus 7, 10. Then multiplication as well would do the same thing. 2 will add 2 to all the elements in the vector. That's 4, 7, and 5. Then multiplication by 2 would also, in maths or is it physics, we call this is it scalar multiplication of vectors. Raised to power 2 is going to do that for every element in the vector. And here, this is going to, like the mapping I showed the other time, 2 raised to power 3, 5 raised to power 2, 3 raised to power 1. We have that here. Then here, so this is what I was saying the other time, that whatever we do, make sure that they are either the same lengths, as the same number of objects in both vectors, or multiples of each. For example, the left hand here, the left hand to the multiplication sign here is 2, while the right hand side is 4. So what this will do is to do 3 times 2, 2 times 5, 3 times 3, 2 times 4. So as long as they can complete each other in replicates, then you are fine. Here as well, the same thing, either left hand or right hand side. You can also use the exponents through a vector or any function through a vector. All right. Then products, of course, I think we've done this before. Then we can assign a vector to, or a list or a sequence to an object or variable. That's assign 1 to 5 to x, and is x greater than 5? So let me call x first, so we can see the x 1, 2, 3, 4, 5. So is x greater than 3? Now it will go through each one of them. Is 1 greater than 3? It returns false. Is 2 greater than 3? It returns false. Is 3 greater than 3? False. 4 greater than 3? True. And 5 greater than 3? True. So we are expected to have false, 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 true, true. All right. So false, 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 true, true. And here again, the modular operand, this gives the remainder. So x divided by 2. Remember, x is 1, 2, 3, 4, 5. So x divided by 2. 1 divided by 2. Remainder is nothing, the remainder 1, the 1 still remains, and 2 divided by 2, no remainder, that's 0. So what we'll have, okay, let me run this first so that you see what we'll have. We have 1, 0, 1, 0, 1. That's 1 divided by 2, 2 divided by 2, it remains nothing, 3 divided by 2, it remains 1, 4 divided by 2, it remains nothing, 5 divided by 2, it remains 1. So now we are asking all of this, are they equal to 1? So we should have we should have true, false, true, false, true. Yeah. Okay, so I'm going to run that true, false, true, false, true. All right, so let's assign v to this vector. This vector to v rather. So length, this is what I did earlier. And then the rev returns the reversed vector. It reverses the vector. the other way around. Sort and sort it. Sort works even for texts, for character data, character variable. It can sort alphabetically from A to Z or from Z to A. So decrease, when we add the function decreasing equals true, this would sort it in decreasing order. Now, duplicated, the function duplicated will tell us true or false. So was 13 duplicated or true? False. Was 15 duplicated? False. 11 is duplicated. I think just 11 and 19. All right. So we'll see for the positions where the inputs are duplicated, we'll have true there. Yeah. Okay. So we have true here, true here. Okay. Unique, where it is unique, we'll have true, and then we can have the rank as well. So rank for the ones that have 0.5, for example, where we had 11 and 11, the positions of 11, it calculates the mean and returns the value, I mean the average for each one of them. Okay, then sum. Okay, let me see. V greater than 13 assigned to sum, then sum. Yeah, so we have true, that's V. V is our vector. Is it greater than 13? For every one of it that is greater than 13, it says true. If it is false, it says false. Then is there anything? So the true, false is what we've assigned to sum. Now, if there's any one of it that is true, it tells us here. Is there any that is true? It says true. That truly, this is there's something there that is true. Are all true? It says false. Not all of them are true. All right. Then which one is true? It tells us 2 is true. The 5th position is true. The 7th position and the 8th position are true. Then which maximum? Like the 5th position is maximum, and which position is minimum? The 3rd position is minimum. All right. Now I would give space for just one question before going to the next type of data structure, matrices.
Please, sorry, still on the same application. Thank you for your previous answer to how the level is applied. How do we apply these vectors? Just briefly, please. Thank you.
Okay. For applications, because really our time is fast spent, just for now, try to understand what we are, these concepts. The applications will come as soon as probably the next class, like you start saying it. Because if I start talking about applications now, it will be abstract for us. But a vector is like a column in your data sets. So whatever you can do to a column is what you can do to vectors. Sometimes you want to manipulate it, just like what I was saying the other time. Sometimes you want to manipulate it in 1 or 2 ways, or even bring it out of the data. You do that using vector. Every column in your data set is a vector. Remember the definition I said of the same type. So if we have a data set, we have columns, and we have a column for gender. The gender would mostly be boy, male, female, male, female, male, female, male, female. So that's a type. So that is a vector, and so on like that. So it's not possible to have gender and now have income in that same column. So whatever you can do to a vector is what you can do to a column in a data set. All right, so let's move. For matrices, now vectors are one that in row format, but matrices are, all right.
Listen.
Okay, I can hear you.
Okay, I'm sorry. It is about the summation of 2 vectors. When we say that if we take, for example, 1 vector and plus 2, I don't get really why before to do the summation of 2 vectors, we are supposed to have the same type, the same dimension normally.
Yes. So okay, for this one.
Really, yeah, when we talk about 2 plus
tutor to complete because of the time, so that we just bring the question after we
give
a short space for.
Yeah.
I think that would be better because we are already behind time. Please, bear with us. Just hold your question.
All right.
Let him
So
finish.
Yeah.
Thank you. Thank you.
All right. Thank you. All right. So to create a matrix, you use, for creating vectors, we use C here. But to create a matrix, you write it out, matrix. Then the data is 1 to 8. N row, that's number of row equals 4. Number of column equals 2. So this is a 4 by 2 matrix. You're having four rows and 2 columns. If we run this, we have, okay, so when we run this, nothing happens. You can see M saved in my environment, and then I run the M. We have 1, 2, 3, 4. We would fill out the matrix column wise as 1, 2, 3, 4, 5, 6, 7, 8. However, we can change that. We can tell it to fill it row wise. We'll do that later. Now, the short form of writing all of this out is that, right, matrix 1 to 8, that's the first argument we are passing into. Then the second one is the number of row. The third one is the number of columns. So this will give the same thing. So I'm not going to assign this, and I'm just going to run it, and you see we have the same outputs. All right, then we can slice matrix as well, just like we sliced vectors. So this was what we did the other time. To bring out the third row and the second column, remember when we were specifying how the structure of the matrix, we started with row and then column. So the row comes first. While you are specifying anything we are doing with matrix, row comes first before column, row, column, row, column. All right, so slicing brings, this is calling out the third column, the third row in the second column. So remember, this is still the same matrix. The third row is 1, 2, 3. The third row is 3 and 7. In the second column, that should be 7. So if we run this, we have 7. So the name of the matrix is M. The square bracket is what we use to select or slice, calling out the third row in the second column. Then again, we can call out the second row once we leave the other arguments, the other position for the second argument or any argument blank. We are saying that bring on everything in that argument. So we said row by column. So we passed 2 to here for the row, and here we are saying all the column in row 2. Let's look at it. This is row 2. Of course, there are 2 columns, 2 and 6. So if we pass that, if we run that, we have 2 and 6. Again, give us all the row, because the row is we've left the position for row blank. Give us all the row on column 2. Column 2. Okay, let me just run it instead of showing. We have 5, 6, 7, 8. Remember, this is the column 2, 5, 6, 7, 8. All the rows, there are 4 rows there, 5, 6, 7, 8. So it brings it out 5, 6, 7, 8. This is everything in that column. Now, we can bring out another matrix from the existing matrix. Here we are saying row 2, column 3, row 1, column 2. Here I'm going to run. Why is Team starting? Okay, row 2, column 1, and row 1, column 2. All right, so this is the row 2. Row 2 to 3, sorry. Row 2 to 3, column 1 to 2. Row 2 and row 3, column 1 and column 2. If we scroll back up, you see what we have done there. Now, remember I said R brings, it arranges the matrices by column-wise. It has arranging the number column-wise. So to change that defaults, we'll add another argument by row equals true. So the same matrix, but we are changing how it appeared. 1 to 8 and call Y again. And we have, so this time around is 1, 2, 3, 4. Yes, sir.
Sorry, because of time, we are a little way behind. So can we just round off probably in 1 or 2 minutes time, and looking at how to factor what we are yet to cover into the next lecture, so that we don't stretch people too much.
All right.
Thank you.
Let me just finish. All right. You're welcome. Let me finish this. All right. So here I'm structuring the arrangements 1, 2, 3, 4, 5, 6, 7, 8 into Y. Then transpose, to create the transpose is just specify T. Function is T, and it transposes it. Then another way to create matrix is to use as matrix and assign it to Z as matrix 1 to 6. Again, the default is to arrange it by column. So this is 1, 2, 3, 4, 5, 6. It presents a column matrix 1, 2, 3, 4, 5, 6 because we didn't specify anything. To check the dimension of your matrix, you use dim 6 rows by 1 column, because of course there are 6 rows and we have 1 column. I'm looking for where to stop. All right, so I'm going to stop here. Okay, then the dimension of Z. To change the dimension of this Z now, we pass a vector 2 by 3. So this answers the question, that person's question, how do we apply vectors? Now, remember dimension gives us 6 by row by column. That's 2 arguments. Here we are passing 2 arguments vector into the dimension. That's 2 by 3. If you run it and run Z again, the matrix becomes a 2 by 3, 2 rows by 3 column matrix. So if you run this dimension again, we have 2, 3. You can see the application of vector, like I said. Yeah. So again, we want to ask, is this a matrix? Looking at how to use is this a matrix? Of course, it's not a matrix, because remember I said to create a matrix, you have to specify and use the word matrix or function matrix. So it's going to be, this is be false, and it's not a matrix. Then if we write it properly as matrix 1 to 6, then this is going to be true, because it is we've specified matrix there. So I'll end up finish this class in a recorded video. I'll record a video and it will be sent to us for the rest of the class. So if you have questions, we might not be able to take all of the questions because of our time. You can still send your questions. Then I'll try to treat it along with the videos that we'll be sending very soon. All right. So we'll stop here because of time.